Hello, everybody, and welcome to this webinar on how LoadMaster can enhance your application and API security, particularly with cloud-based applications. And my name is Maurice McMullen. I'm a product manager with Progress, with responsibility for the LoadMaster product. I've been with Progress and Kemp before that since 2014. Just a couple of bits of housekeeping. If you want to ask a question, you can pop the question into the question box just below, and we'll get to those at the end of our chat. So without any further ado, I shall get started. So probably the first question that we would ask here is, why do you want to do security on a load balancer? Well, mainly because we're in a very unique position on the network to inspect the application level traffic because we've decrypted it. Where normally a load balancer is acting as an SSL proxy. We're offloading the SSL processing. We're decrypting the traffic coming in so we can see inside the request coming in. So we're in a position to take action on it. You can see there that there's still a network firewall there of some description. So that network firewall could be from your cloud provider, or even on your on-premise network, and it would be providing a lot of the network level protection. For example, DDoS protection. It would have all the ports configured to make sure that certain sorts of traffic are blocked at the edge, etc. So it's doing that network level stuff. And on the load balancer, we've got an opportunity to apply another levels of security when attacks are based not at the network level, but at the application level. So these are, hackers that are trying to exploit, application weaknesses, maybe poor user authentication, weak credentials, credential stuffing, various attacks that happen above the network level. From the firewall's point of view, this will all look like legitimate, traffic going into a website or a web application or an API. So given that privileged position that we have in the network, LoadMaster has has the capability to enhance the security. It isn't going to solve all security problems. We still need to be doing all the other things around this here as well. So what we'll do is we'll have a look through the capabilities and some of the use cases and how these can be applied to API and application security. And again, this is just looking at some of the features, and I'll sort of tie all of that together at the end and looking at how they all come together in the various use case scenarios. One of the first things that we can do here is IP reputation. Essentially, we've got these lists of deny lists of IP addresses and IP reputation lists, and we provide that list automatically, and it's on a daily update from Progress, and that has a list of IP addresses that have been identified as bad actors on the internet. So immediately, if a connection is made from one of those IP addresses, the LoadMaster will refuse to make that connection. Okay, so it'll just drop the connection. So that's a way of implementing. You can create your own custom defined list as well. So if you see traffic, malicious traffic coming at you from a subnet, by the way, this works at a subnet level as well. So if you see something come from a particular subnet, you can say, okay, I want to block that. And we actually have essentially a drop-down list to allow you to block a whole country. The Obviously, blocking a whole country, it's not totally foolproof. People can use VPNs. There's the allocation of IP addresses does not necessarily always fall on exactly on a country boundary, or border. So, but it is a good way of let's say, blocking rogue states. I'll put it that way. Also, there are use cases there, and this is what we call geofencing. So, uh, uh, I'm based in Europe, for example. There's a lot of US websites, if I go to them, that they say won't accept my connection because they don't apply the GDPR privacy rules that people in Europe are used to. So it's a way of confining, and if you've got no reason for let's say having people from outside your own country connecting to your services or applications, then it's a way of locking that down, because you can also invert this here, where you deny everything and only have permit lists, so you can work it both ways. So that IP reputation, even though I mentioned earlier on that we work at the application level, this is actually at the network level. Okay, that we do this. Another thing that we have is rate limiting. Now, you may think, what value has rate limiting in the context of security? Rate limiting is useful to prevent services from getting overloaded by a bad actor. And overloaded could be that somebody's doing an application level denial of service attack. So rather than, let's say, a network attack where you're getting a flood of network level packets, whatever method they're using to do that, this is where, let's say, a bad actor is excuse me, repeatedly attempting to log in, repeatedly accessing an API purely to consume resources, to slow down your website or whatever. And on the login attempts, that could be somebody trying to brute force your authentication. So they may be doing some credential stuffing, whatever it may be. So being able to do rate limiting has a security slant to it there. It can help mitigate against particularly those application level denial of service attacks. Can also again slow down somebody trying to do let's say a repeated login attempt. So these can be applied at various on various parameters in terms of, you can see there concurrent connections, the amount of connections per second, the number of requests, even to limit the bandwidth there. And this can also just have a use if you, let's say, have an API and you want to be able to control that API, so no particular user hogs all the capacity of the API, so it's useful there as well. And we can apply rate limiting, on a, let's say, an application level or a service within an application. So, an API, for example, a specific set of calls within that API could be restricted. On an application, it could be specific application URLs. You could rate limit them. You can also apply rate limiting based on the source IP of the traffic as well. So there's a number of different ways, and you can also customize the response codes there that you give back. So you could give let's say, like a standard response there would be a 429 too many requests, or you could customize that and just go a 503 service unavailable type thing. So there's a number of customizations you can make there to make that. If you're doing it from a security point of view, you could customize that service request, let's say, to come back with a 404, to tell people to go away, or a 503s telling try again later type thing. So that's on rate limiting. Authentication, we have a lot of authentication capabilities in LoadMaster. Just to, this is a high level type of summary. We can have multiple identity providers in there. So, it could be, Azure Active Directory in the cloud. It could be a local radius server, any of those. And we can act as an authentication proxy and do pre-authentication before somebody gets to the application. And the application, for example, itself, it could be a case of the application has got no concept of a user, but we can still authenticate access to that application through the LoadMaster. And as you can see there, we've got custom forms that can be applied there as well. And we support authentication tokens, two-factor schemes as well in there. So it performs a number of functions there. Number one, acting as the authentication gateway, it does pre-authentication, so you don't get to the application until you've successfully authenticated. But it also allows you to use things like two-factor authentication that may not be supported by the back-end application. And also you can do things like single sign-on as well. So pretty standard stuff there that you would expect an authentication gateway to do. LoadMaster can, in a cloud environment where you've got a multi-cloud environment, you can consolidate all your authentication to the LoadMaster platform, and again make it easy to use the same authentication across all your clouds. So rather than having to configure your AWS environment to use maybe local AWS authentication, or trying to federate it with Azure Active Directory, you can offload all of that there to the LoadMaster. It essentially acts as the front end authenticator for all of these. So it can be very useful there. Just on the forms there, you can customize those forms, but you can also drop in captchas there as well as an additional thing. And you can actually just do a captcha on its own without any authentication. Now, a captcha can actually prove a useful defense against some of those bot-based attacks, where essentially the captcha, it's a weak protection, but it may be enough. It's the old adage: you don't have to be able to run faster than the lion, they just have to be able to run faster than the other guy. So the bot comes to your site, it's got a captcha, and it'll say, I'm not putting in the effort to try and break that captcha, I'm going to go to my next target. So it's a deterrent rather than an absolute prevention. So we can, again, easily overlay that on an application that has no concept of authentication, captchas, two-factor authentication, any of that. And next, I'm going to look at content rules. And content rules are a very, very, very powerful feature within LoadMaster. They can do many things. Okay, so I'm going to look here at this here from a very much a security point of view. So looking first of all, one of the things you can do is add or modify HTTP headers. And this can be very, very useful because you can create a standard set of security headers and insert them into all of your traffic. So for example, you can see there below, we could prevent in page framing, for example, or force everything to be the content security policy being HTTPS, so there's no side loading of JavaScript or no side loading of other. You can enforce all of those. And then again, there's a lot of security headers that you can put in there. Adding secure attributes to cookies, etc. All of that thing, and it may be that your application at the back end doesn't support this here, or it's difficult to manage that across multiple different servers. You can do it all in one place with LoadMaster. You can create a policy. You can actually create a policy outside the LoadMaster and apply it via API and apply it across multiple LoadMasters. So you've got consistency of application there as well. And it's yeah, and again, this can be applied at multiple levels within, an application, either the whole complete application, only apply it for certain directories or certain API calls. Again, you've got quite a bit of flexibility there. Another thing you can do with content rules is to rewrite URLs. So there's a lot of reasons that you'd want to rewrite URLs. Sometimes it's just to clean up the URLs. Sometimes there may be long paths in there, or sometimes it's to obfuscate what's happening in behind. So again, even though the web server at the back end might be sending out headquarters/analytics, at the front end, that'll appear out as analytics. And again, on the way back, the load balancer will do it. So it's very useful there to, particularly from a security point of view, it's good. It's a good way of obfuscating some of the information that may be leaked about the infrastructure that sits in behind, whether it's multiple servers or location information, whatever it may be. The next thing is being able to actually rewrite the body. This is the body of a page, so the actual content inside a page. So the classic use case for this here is where you've got an older application where that application insists on not having relative URLs in there, but populating or inserting the full HTTP, etc., in the actual code of the HTML code of the page. And of course, if you put that through a load balancer, you get HTTP out the front, it doesn't connect, it fails. So you can rewrite that so that your HTTP becomes HTTPS. There's a lot of other potential use cases in there. From a security point of view, it could potentially be used as a way to prevent exfiltration. So you do a pattern match. Again, these content rules work on pattern matching. So it's standard regex type patterns that it'll work on. So for example, you can look to identify something like a social security number or a credit card number and see that they're coming out, and you say, no, that shouldn't be published externally, and you can rewrite that there with asterisks or whatever. So there's various things that can be done with that there. A lot of this here will be application specific, and a lot of it is around making those applications work correctly from a security point of view, making sure they've got HTTPS at the front. Other things you can do with content rules, obviously, is block traffic and do traffic redirection, traffic management. Okay, so for example, if you have an application and it has a /admin, where if you go there, you can do admin type features, then you can block that there, for example, by either just doing a redirect of everything back to the root, or you could actually block the connection and return a status code. So again, there, this is part of if you're looking at the status code bit there, from an API point of view, it's very interesting that you may want to change the response there coming back from the API, so that a 405 method not allowed, okay, would indicate there is something there at that URL, but I'm just not doing it right. So the hacker would continue there. You could actually, rather than returning that 405, you could return 404, which says, hey, there's nothing here. So again, you can use this here to to block and obfuscate. And if you really start using content rules, you can actually essentially implement a zero trust network environment. So here we have, just as an example, this is where, based on where the network or user is coming from. So this is where we've taken a deny everything approach and then enable. So everything is denied. Somebody logs in, we check what network they're on. Based on that network, the rule will say, okay, you are a member of the admin group, so therefore I will give you access to the following resources, and so on and so forth. So these content rules are extremely, extremely powerful. And again, this is a way of getting started on this zero trust, the idea. You get to nothing unless you're explicitly allowed. The other big security capability within LoadMaster is our web application firewall. So again, you may be familiar with web application firewalls, but just to give a quick 101 on it, it's a protection against web exploits. So all traffic coming through, all requests coming through are inspected. They're checked to see, does this look suspicious? Very much like a virus scanner would be looking for the fingerprint of a virus. The WAF is looking for the fingerprints of an exploit. And these exploits are, they're categorized into what we see there as the OWASP top 10. And the OWASP top 10 is the OWASP group, essentially. It's a non-profit, and it categorizes these known exploits. Every year it issues a new list of vulnerabilities. It's it's things like SQL injection. There's a lot of these exploits, and they're found in not only homegrown applications but in commercial applications as well. It's an ongoing problem, and there's statistics out there that show that there's a lot of applications are vulnerable to this here. So this is almost like a a fundamental building block of security for any web application or API, is to put in a web application firewall. It can catch all these well-known vulnerabilities, okay? And then you've got the option then to add your own custom rules, or for your own applications if necessary, and also to do tuning of this here. Again, false positives can be an issue here. So again, you can adjust the sensitivity of the web application firewall to meet your own requirements. Looking at SSL policies and certificate lifecycle, just SSL policies. When you configure SSL on a service, you have a lot of cipher suites there. And the cipher suites essentially define, okay, I'm going to use this type of encryption for my bulk encryption. I'm going to do my key exchange this way. I'm going to do my digital signatures using, whatever. It defines the combination that you're going to do. Some of these cipher suites have been around for a while, since SSL was around initially. Some of them have become weak. In other words, they've had exploits there that people have decided they're unsafe to use. So we would have a best practices suite, set of cipher suites there that we would offer to, and it's our default in there. It may be that if you're in a regulated industry, or one of these cipher suites suddenly becomes compromised in some way or other, you can customize these cipher sets as well. Create your own best practices, and again, you can apply that to all your web applications. Again, over the API, you can just set everything across. If you have multiple load balancers, you can do it over the centrally manage it that way. So it gives you a consistent way of implementing that policy. And again, measuring that there in terms of if your audits, etc. It's a box you can tick there to make life a bit easier for you. I mentioned certificate lifecycle management here because we've all heard the stories of somebody's let a cert expire because the person you monitored is on vacation, or there was nobody monitoring, or whatever. Okay, and obviously, one of the mantras of security is, availability is part of what you're trying to do there as well. And if you lose if your certificate expires, then you lose access to your website, so your availability is gone. Within LoadMaster, we support the ACME protocol, and that at the moment that certification authorities such as Let's Encrypt and DigiCert support that as well, and that allows us to automatically renew the certificate. Okay, and there's various parameters that can be set in behind as to how far ahead of expiration you do this automated renewal of certificates. And practice over recent years has been that certificates have a shorter lifetime. It used to be that certificates were around for years. Now lifetimes are more like months. So that certificate lifecycle management is can be quite a burden. And again, within LoadMaster, we've supported these automated certification authorities so that it's one less thing that you have to worry about. Okay, so that's a quick flyover of some of the security capabilities within LoadMaster. So I'm just going to pop into some of the use cases now, just to give you an idea of how all of this hangs together. So here we have a multi-cloud API gateway. So this is where you have some services that are being delivered via an API. They're hosted on different clouds. So again, how do you present that there as a single API? With LoadMaster, again, content rules, etc., you can make all of that appear as a single API to the user at the front end, and essentially map, as the request comes through, map them to the correct backend API service as well. So things we can do there, if it's an authentication, we can do certificate-based authentication there. So again, from an API point of view, that's often a better way of doing the authentication. We can do the IP reputation bit. We can do the WAF, because it can apply as well to APIs. We can do rate limiting, which in an API context can be very useful. And then we can use content rules to control access. So that controlling access could be as simple as, for example, if we've got that REST1 API may have some features that you only want available internally, so you can block those off from access for external users, or you could have, based on the user being authenticated, what group they're a member of, you can open up more or less of the API to that user. So there's quite a lot of things that you can do there with content rules to essentially present this fragmented set of APIs at the back end to the front end as a unified single API with a single authentication in there as well. So that's an API centric view on that. Looking at application protection, again, very, very similar type thing, just looking at a simple application, load balance across a couple of servers. You've got your authentication at the front end. You can have single sign on there. Potentially you can use CAPTCHA And again, you got the IP reputation, you got your SSL proxy, offloading the SSL, something that I just on the previous slide, we can re-encrypt to the back end. So if, for example, if I have my load balancer consolidating 3 APIs on different clouds, then I would want to re-encrypt the data going out because it's going back out potentially over a public network. And again, just looking at this application here, again, the WAF is there. And then you can see, like with our content rules, we can, do URL rewrites, add in security headers to put, the maximum security possible for the application, etc. So very, very simple way of layering in multiple security capabilities in there to add to that overall application security. And just to expand that a bit, multi-application protection. Again, you get different applications on different clouds or even on-premise here on this here. And at the front, you can have your authentication. It could be into somewhere, using an IDP such as Azure Active Directory, for example. Authenticate users, do all your IP reputation, do your SSL offload, do the WAF, do the policies, and at an individual level, then we can further refine again, using rules, essentially implement a zero trust environment. And again, that could be on a per application basis. It could be across multiple applications. And actually on the slide here, I do have in the SSL re-encrypt there as well. So this gives you an idea of how all of this here comes together, that all these different security building blocks that we have can be used to essentially deliver enhanced security for applications, APIs across any of the web providers or any of the cloud providers, also on-premise as well. It doesn't matter. It's consistent regardless of what platform that you're on. And I am now at the Q&A session, so I'm just looking at somebody has told me my chair needs some oiling. I apologize that I've got a squeaky chair. Right. Thank you very much for that feedback. I shall take note of that. Right. Okay. Sorry, that threw me a little bit there, the oiling of the chair. So I've got a question here. What authentication providers are supported? LoadMaster can support Radius, LDAP, Active Directory, whether local Active Directory, Azure AD actually can do the federated version there as well. On that, SAML, OAuth, Kerberos, etc. So yeah. Question: where is the load balancer placed for the multi-cloud scenario shown? Okay, the load balancer can be anywhere, essentially, as long as you've got connectivity to the application services. You could host it on premise or in any of the cloud providers. Again, it depends very much on your application requirements there, because if, let's say, you put it into the Azure cloud, okay, so if you got traffic coming into the Azure cloud, you could redirect or trombone the traffic out and send it to AWS. And now tromboning would have a cost there, so you might decide, actually, I'll put a load balancer into AWS as well, but front everything from Azure, and Azure would just do a redirect to AWS, and then all your traffic would go directly to the AWS instance. How to configure a virtual server when the user has to authenticate to a real server with the user certificate. Without having a live system here to demonstrate that on, essentially, I'll try and explain it in words, and hopefully we'll be able to clarify. You can have any authentication on a virtual service, okay? And essentially, certificate provider is just another service provider there. So I can't really get into just as I go through the technical part of that. There, we do support things like all the OCSP stuff, OCSP stapling, all those sort of things to on the website, adding that in. But we can do an authentication with just based on a certificate on its own, or a certificate plus user credentials. I'm not sure if that totally. I actually, it doesn't answer the question. All right. Okay. Is it possible to use? Right. So auto renewal of certificates, if they're made if you've got your own in-house certification authority, the automated renewal is based on the ACME protocol. And if your internal certification authority supports the ACME protocol, then you should be able to. And I say should because I'm not aware of any implementation at the moment doing this here, but it should be able to do the auto renewal. Some of that depends on how the certification authority will actually do a validation of ownership. Does it request a token, something signed digitally? Does it need a web page with specific content to be dynamically provisioned as part of the authentication? There's a number of different mechanisms, but if it supports ACME, then we should be able to do it. All right. Okay. So, question here on, we are evaluating WAF at the moment, and will we get updated rule sets, or is it only the IP reputation that are updated on a daily basis? Okay, so the WAF rule set is essentially the OpenCRS rule set, okay? And as updates are made to that, we push those out, or we make those updates available. So it's not on a daily basis. It's much less frequent than that. Yeah. Okay. Now, how LoadMaster WAF offer API and bot protection? Again, the WAF level protection for APIs and bots is very much, as I mentioned there, the CRS rule set. It's the protections that are provided within that. Okay. That bot protection, again, there are some essentially Snort, if you're familiar with Snort as a product. We have Snort type capabilities in there, so we can do some lower level network type bot protection. And again, the protection from, let's say, rate limiting, etc., can provide some protection around that as well. Do we do probably the way that maybe the question you're asking there is, do we have any sort of an AI-based learning system in behind the WAF that's learning about bot behavior, etc.? The answer to that is no, we don't. Okay. Right, another question here. Can a single load balancer host multiple APIs and applications at the same time? And is there a licensing cost? Okay, on the first part, yeah, you can host multiple instances of applications and APIs. You can, there's no, I don't think, I'm trying to think what the limit it is. It's thousands as far as I can recall of services that a virtual service essentially is an IP address that somebody can connect to get to an application or a set of APIs. So we can support thousands of those. So there's no restriction in that. The only restriction really there is the throughput of the actual appliance. So there's not a per application cost or license for that for APIs. Okay, and that's all the questions that I have. And if there's no further questions, what I'll do is I shall go and get some oil to oil my chairs to stop it squeaking, and also learn to be a little more stable when I'm presenting. Thank you all for your time, and I hope you all have a good day. Thank you very much.